Here we want to find the integral of x to the k dividing by e to the x, where k is a positive integer. And so we want to find this improper integral. And so first, let's do the case where k is 1. So if k is 1, then we get x dividing by the integrand will be x to the first dividing by e to the x, which can be rewritten as x times e to the negative x. And so we end up with the integral x times e to the negative x. And to find this integral, we use integration by parts. And recall that the formula for integration by parts is the integral of u times dv is equal to u times v minus v times du. And so in this case, let u be x, and then let this part right here be dv. So we have du dx will be 1. And so du is equal to dx. dv is the same as 1 dv, and so we integrate both sides. The integral of 1 dv is just 1 times v, which is v. And then recall that the integral of e to the negative x is negative e to the negative x. So the integral of e to the negative x is negative e to the negative x. And so we have uv, this is u, this is v, and then we'll evaluate from 1 to infinity, and then minus the integral of v is negative e to the negative x, and times du is just dx. Minus negative becomes plus. The integral of e to the negative x again is negative e to the negative x. Integral of e to the negative x is negative e to the negative x. And again, we need to evaluate from 1 to infinity. X times negative e to the negative x is the same as negative x dividing by e to the x. This is e to the negative x, and so when we move it to the bottom, it becomes e to the x. And then this can be rewritten as 1 over e to the x. And then we have a minus right here. And so first, we'll let x approach infinity. And so we get the limit as x approach infinity of negative x dividing by e to the x. And then the lower limit of integration is 1. So in the place of x, we have 1 and then 1. And then similarly over here, we get the limit of 1 over e to the x as x approaches infinity. And then when x is 1, we get 1 over e to the 1 first. The limit of negative x divided by e to the x as x approaches infinity, we get infinity over infinity. We get negative infinity over infinity. And so we can use L'Hopital's rule. So take the derivative of the top, we get negative 1, and then the derivative of e to the x is just e to the x. And then we get negative 1 divided by infinity, which is 0. So this will be 0. So we get 0 minus negative 1 over e. And similarly, this will also be 0, 1 divided by infinity. So we end up with 1 over e plus 1 over e when k is 1. And so the integral becomes 1 is equal to 1 over e plus 1 over e when k is 1. And now let's look at the case for when k is 2. So when k is 2, the integral becomes, the integrand becomes x squared. And so when k is 2, we get x squared dividing by e to the x, or times e to the negative x. And again, we use integration by parts. We'll let u be x squared, and let dv be e to the negative x times dx. Du dx will be 2x. And so du will be 2x dx. This is the same as 1 dv, and we did this earlier. And so v will be just negative v to the negative x. And so now we'll get uv minus integral v du. So this is u, this is v, minus, and this is v, and this is du. So we end up with x squared times e to the negative x. And then here we have a 2, and then here we have x, e to the negative x times dx. But we just did this. We just completed this integral right here earlier. And the result for this integral was 1 over e plus 1 over e. So this part right here would be negative x squared dividing by e to the x. And we evaluate from 1 to infinity. And again, this integral we have just finished. This integral right here is 1 over e plus 1 over e. The integral right here, the same thing. If x approaches infinity, then we get infinity, negative infinity over infinity. So we use L'Hopital's rule. Then we get negative 2x divided by e to the x, and then apply L'Hopital's rule again. We get negative 2 divided by e to the x, and so we get 0. So again, this integral will be just 1 over e. And then this will be 2 times 1 over e plus 1 over e. And so when k is 2, this is what we get. And now let's look at the case when k is 3. So when k is 3, then the integral will be x to the third divided by e to the x, which is also can be rewritten as x to the third times e to the negative x. And again, we'll use integration by parts and let u be x to the third. So du dx will be 3x squared, and then we get du is 3x squared dx. And then dv will be e to the negative x dx. And then similarly, we'll get the same result. V will be e to the negative x. And so we get the u, which is x to the third, and this is v. And again, this will be v du, so it will be negative v to the negative x, and then du is 3x squared. So we end up with this plus 3 times x squared, integral of x squared times e to the negative x. But in the earlier step, we found that the integral of x squared e to the negative x is 1 over e plus 2 over e plus 2 over e. And then this integral right here, this is this part right here, if we evaluate from 1 to infinity, then we also get 1 over e. And then 3 times all of this, we'll get this result. And then we put them all together. So when k is 3, this is what we get. And then when k is 4, then we'll get x to the integral of x to the 4 times e to the negative x. And then we'll use integration by parts again. And then we'll end up with this result. And now let's put it all together. So these are the results for when k is 1, k is 2, k is 3, and k is 4. So when k is 2, then it'd be just 1 over e plus 2 times the result of k when k is 1. When k is 3, then it'd be 1 over e plus 3 times the result for the case of k when k is 2. And then when k is 4, it'd be 1 over e plus 4 times the result for the case of k is 3. And now for k equal to 5, then we'll follow this pattern right here. It'd be 1 over e plus 5 times the result for the case when k is 4. And so if we multiply this out, then we get 5, we get 20, 60, 120, and 120. So this is 1 over e, this is 5, 20 is the same as 5 times 4, 60 is the same as 5 times 4 times 3, 120 is the same as 5 times 4 times 3 times 2, and then 120 is the same as 5 factorial. And so when k is 6, then we'll get 1 over e, 6 over e, and then we get 6 times 5 over e, 6 times 5 times 4 over e, 6 times 5 times 4 times 3 over e, and then 6 times 5, 6 times 4 times 3 times 2 over e, and then 6 factorial over e. And so in general, x to the k times e to the negative x, again k is a positive integer, then we will get 1 over e, k over e, and then k times k minus 1, and over e, and then k times k minus 1 times k minus 2 over e, and then all the way down to k factorial. So this is the result.